This is from 2019 and it's a calculator problem. So we're looking at fish entering and leaving a lake, right? And so we've got a function E of t that models the rate that they enter and L of t that models the rate at which they leave. So we want to know how many fish enter the lake from t equals 0 to t equals 5, from midnight to 5. So that should be straightforward enough. To find an actual amount from a rate function, you just integrate that rate function on whatever interval you're interested in. So the integral from 0 to 5 of E of t dt comes out to be 153.47 something, 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 something. And it asks you to round to the nearest whole number. So we'd say 153 fish. And 1 point for the correct integral setup and 1 point for the correct answer. And so anytime you're given a rate and you want the amount of that thing, just integrate it. Any questions there on part A? All right, part B, we want to know the average number of fish that leave the lake per hour during those same 5 hours. Well, this is the average of a continuous function, right? So the average of a continuous function is the mean value theorem for integrals. 1 over 5 minus 0 times the integral from 0 to 5 of our L of t function, since we're now talking about leaving the lake. And that comes out to be 6.059 ish. And that one was 1 point for the right setup and 1 point for the right answer. Any issues there with part B? All right. Part C. Now, part C is asking us when between t equals 0 and t equals 8 do we have the greatest number of fish in the lake, and we have to justify our answer. And anytime it says justify your answer, make sure you've got some sort of justification. Otherwise, you're not. There's definitely a point associated with your justification. So make sure you do that. So we got to think about this a little bit. The greatest number of fish in the lake would occur potentially at an endpoint, right, at 0 or at 8, or it would occur when the derivative of a function that represents the number of fish in the lake is equal to 0 or undefined. So let's write a function. We'll call it f of t that represents the number of the fish in the lake. Well, let's just call f of t number of fish in the lake. We don't need to write something explicitly for it yet. We might in a little bit. But if we call that f of t, we could say that the derivative of f, the rate of change of the number of fish in the lake, right? That'd be what f prime of t would be. That'd be the rate of change of fish in lake. Okay. And so what does f prime of t equal? It should be the rate at which they're entering minus the rate at which they are leaving. Right? That's the rate of change of the fish in the lake is the rate of change at which they enter minus the rate of change at which they leave. And so if we want to know when f prime is equal to 0, we just need to know when E of t minus L of t is equal to 0, or when it's undefined. But if we look at those two functions, we'll see that if we look at E of t and L of t, there's no values of t for which those are undefined. So we really just care when does E of t minus L of t equals 0. That's a potential location of a max or a min. So you can just use your graphing calculator to get that's at around 6.20356. And you would put that on a sign chart. And since you'd be looking at the graph, and I've got the graph up here in Desmos for us to look at, this is the graph of that function. We know that to the left of that, this E of t minus L of t function, the derivative of f, is positive, and to the right of that intercept, it's negative. So that tells us if it to the right it's positive, to the left it's positive, and to the right it's negative, that tells us that we have a local max at 6.20356. And this is E of t minus L of t, right? This is a sign chart for this function, f prime. Tells us f increases, which means number of fish increases, then number of fish decreases. So the maximum at this t value, 6.20356. Does that make sense to everybody? Any questions on that? Okay. Now,
do you not have to check the endpoints for this question, because those you can't have them at the other side?
So we know that the function is always increasing between 0 and 6.2, and we know it's always decreasing after that. And so if it's always increasing and then always decreasing, we know that this must be the highest point. So with the sign chart and saying that this is the function E of t minus L of t, we know that it couldn't be at the endpoints. Now, there's another way to go about this. You could write this out and say, all right, we got this function f of t. Actually, let's call it something different than f this time. Let's call it, what did they use? They used E, they used L. We just tried to use f. Let's just call it g. Actually, let's call it r. Let's call it r of t. I think that better. So let's call r of t equal to the integral from 0 to t of E of t minus L of t dt. And so, well, I always do this. E of x, let's make these a different variable, minus L of x dx. And so let's say r of t, this is the number of fish in the lake. We'll say this is the difference in the number of fish in the lake from t equals 0. Right, and that's what this r of t is. It's the difference in the number of fish in the lake from t equals 0. It's how many of them entered from 0 to t minus how many left from 0 to t. So it disregards the initial amount. It doesn't matter how many were in there at the beginning, but this is the amount that entered minus the amount that left. And so it's the difference in the number of fish. And so we could go in and say r prime of t is equal to E of t minus L of t, like we just did a minute ago, set that equal to 0 and get that same t value of 6.2053, whatever it was. And if we wanted to, we could then not bother with the sign chart. We could just say, well, if this could be a max when t is at either of the endpoints or when it's at 6.2053. And then you would plug in values into the difference in the number of fish in the lake from t equals 0. So at t equals 0, we'd be at 0 difference from what it was at 0. And at t equals 6.2, you'd plug this integral into your calculator and come up with a value of 135.01492. And you'd say, okay, there were 135 more fish in the lake at 6.2 hours than there were at the beginning. Then you'd plug it in at 8, and you'd get something like 80.91, something, and you say, all right, well, at 8, there's 80 more fish than there were at 0. So clearly the maximum number occurred at 6.2053 by checking the endpoints here and the critical value that we got. But we would need a function here to represent the number of fish different from the beginning. Does that make sense?
Yes.
Yeah. Okay. So this is one way to do it. Personally, I prefer doing it this way with the sign chart and just calling this the derivative of the number of fish in the lake. But that's either way is fine. Oh, and the point breakdown for this, we just asked about that. 1 point for setting E of t minus L of t equal to 0 in either of those cases, whichever way you decide to do it. 1 point for the answer of 6.2053, and 1 point for your justification. So either a sign chart or a chart that shows that the endpoints and the only critical value and what their values were. Good? All right. And then last thing for today, part D, we want to know, is the rate of change in the number of fish in the lake increasing or decreasing? So what is our function to represent the rate of change of fish in the lake? Rate of change of the fish in the lake is the rate at which they enter minus the rate at which they leave, right? So this is for part D, we're looking at E of t minus L of t. And we want to know, is this increasing or is this decreasing? Well, how do you tell if some function, little f there of t, E of t minus L of t is increasing or decreasing? You look at its derivative. Is f prime greater than 0 or is f prime less than 0? So the derivative of E of t minus L of t is E prime of t minus L prime of t. And we want to look at this at t equals 5. And you're given your calculator, so all you have to do is type in this function, E of t minus L of t, use the derivative calculator on your thing at 5, plug it in, and you get a value of negative 10.7228, which is less than 0. And so we would say that the rate of change is decreasing at t equals 5. And 1 point for considering E prime minus L prime at 5, 1 point for decreasing with your explanation that this is less than 0. Good or no?